Okay, in this first video I will show you the way how to create a project in STM32 and then write and build and download and test the code. Alright, so for this project we will work on the simple projects. So start with the offline and then create creating project, press blue button, release, if wait for the button press, hit the button and wait for the button release, then print out running, and then in the sub loop wait for the switch. If the switch press, then on that. If the button is released, then toggle that for each 100 millisecond. Right, so we go to the STM32CubeIDE, double click, and then click on create a new STM32 project. And next, go to the MPU sector, this one, right? Click to the MPU sector, type on STM32 F401RE T6. Right. Next, click on this, right? This row, and click next. And next, click on untick the use default location. Browse. Right. I want to put it on the STM32 F401RE. I create a new folder. First project, say the same name, projects number 1. Okay, then click on it, select the folder. So the folder now is STM401RE project number 1. Next, click on in name. You can write them my first project. See, right, my first project, or maybe you can name it as switching LED. Right, switching LED. Click on finish. Ensure that target language you see executable and STM32 Click on finish. Okay, next, maximize it. This STM32MX. This is STM32MX. So in this project we have the, we use the serial port. So using the polling mode, click on connectivity, USART2, asynchronous. Then just accept this parameter because we use it in the polling modes, right? We discussed it in slide number 5 in a second. Alright, next we can go to the pinout. Next, go to the PC13, left click and select GPIO input. Next, we go to PE5 and select it as GPIO output. Remember that the LED is attached to PA5 and is identified and the push button is connected to PC13. PC13. Sorry. PC13 here. And it is active low with a pull up resistor already. So if we click on the system view, click on GPIO, if we check the PC13, it is input mode, no pull up and no pull down, because already the resistors are already there, no need to set the pull up or pull down. Next, the GPIO level is low, right? Means that we want this to be 0. If we send 0, it is 0. If we send 1, it is 1. Alright, so you can have a tricks on it. Just play around with it. If, for example, if you want 1 means 0, then you can, or invert it, then you can select this one higher. So it will invert. And next, GPIO mode as output push pull. You can turn it to output open range, but for the active high, we need the push pull, no pull up, no pull down. The speed you can select low, medium, high, very high. But for the simple application, we select low. Alright, that's all. Alright, next we go to the clock configurations. So simply we can set the clock up to 84 megahertz. But say we want to 52 megahertz, type 52 and enter. Click OK. So the application will resolve the clock, right? The suitable clock. So we set already the pinout. Next we go to the, over here we have the gear, symbol gear. Click on it. That's generating the code. Okay, now we have already code here. The codes in the, click on this main.c. Alright, so we have the code here. Okay. So for this, okay, we write code only in between the begin one and end. Within this begin 0, I mean within begin and end, each of the place. For example, here we put includes. Alright, we're going to use the serial port, so we need to type the pound inc, then control and space, include standard IO. Yeah, you can type standard std, okay, IO. Alright, O, okay, we have that, enter. Next, IN, then we include the standard library, no, sorry, string, that the one that we're going to use, H. Alright, next we go to the in this code we're going to creating a project. Press blue button. I copy that one. Oh, cannot copy it. Copy it. Okay, copy this one because later I want to use it. Alright, the first one I want to off the, so I tap HAL, the LED I want to, and followed by GPIO underscore right. Okay, next change this one to E, change this one to pin underscore 5. Okay, pin underscore 5. the pin state is GPIO underscore pin underscore to off, right? It is certified, so we need to reset it. Okay, next we want to string copy into TX2 buffer. Say we have buffer, we need a buffer to transmit, and then we print out this one, creating project /r/n. Next we type HAL underscore UART underscore transmit. Okay, we have that one, so we transmit to UART2 the alright UINT8 underscore T asterisk TX2 buffer, because this TX2 buffer later we will declare it in character, so we need to change the pointer into UINT8 underscore T. That is one example of the typecasting. String length TX2 buffer, and the time out of 10 milliseconds. So the time taken for us for the controller waiting to send the signal. Okay, so we need the TX2 buffer here. Copy this one. Go to the global and type here character for the 100. I say 100 empty space for buffer. And next we wait while HAL underscore GPIO underscore read pin GPIO E GPIO pin underscore 13. Oh sorry, GPIO C. This one GPIO C. Okay, because we know that the post button is here. PC13 is connected in that way. Alright, if that is a curl, GPIO underscore pin underscore set control space. Alright, we wait there, and then delay HAL underscore delay for 10 milliseconds. Next we wait again while HAL underscore GPIO underscore read, then read from port C pin number 13. Okay, is equal to GPIO underscore pin underscore reset. Okay, next we type HAL underscore delay, okay, for 10 milliseconds, and finally we want to print running running. So we can copy this one first, place it here, and copy this running and place it here. Okay, so that's all code for the in the user code begitu. Okay, so we off LUT, then print creating project, then wait for the button to be pressed and wait for the button to be released, then print running, then in the loop, super loop, then we wait for the now check if S1 is pressed, then we on LUT, else toggle LUT, and then delay. Alright, so in the code here, you write the code here. So if HAL underscore GPIO underscore read from GPIO C GPIO pin underscore 13 is equal to GPIO underscore pin underscore reset if press, if it is press, right, then you write to the GPIO, right, GPIO A GPIO pin underscore 5 pin state to on must be GPIO underscore pin underscore set, and because this is active high again and the LED is active high. Alright, next else then we type HAL underscore GPIO underscore T or toggle GPIO A GPIO pin underscore 5. Alright, and then delay HAL underscore delay 200 millisecond. Okay, but before that we have something else here. We want to print out, say we want to print out count. So count must be, okay, if you want to print out count here, so count must be what, set here. If you go on top, okay, then say we use UINT8 underscore T CNT equal 0, set it to 0, and next, okay, we can print it here, right, as printf to TX buffer, okay, to TX buffer, comma, double quote, /r, oops, printf into TX buffer, double quote, /r/n, count is equal to %d, then CNT plus plus, right? After we print, then we increase count. And next we transmit it. Okay, transmit it so we can see it. Okay. Compile, click that hammer symbol or build, right? Compile a bit. Next, run. Okay, if you have a problem something like this, go to the switching to the STM cube and next regenerate the code. And then click run. Okay. Alright, next time if you click run, okay, then it comes out like this. Okay, next we can go to the desktop. Okay, click on Tera, double click on serial, ensure that the correct and correct port is selected, COM4, correct COM, click OK, and then click on setup, and then go to the serial port, and then tap on 11520, click OK. Right, you can clear the screen and press the button. Okay, creating project, press blue button, and press again blue button and release. So you can see that it is running. Okay, so that's all. Bye bye.